This video covers section 3.6, parallel and perpendicular lines. Objective 3, determine whether two lines are perpendicular. To show you how the slopes work for two lines that are perpendicular, I'm going to start off by drawing a graph whose slope is 1/9 that passes through 0, 0. That's a very small slope because you go up 1 and over 9 from 0, 0, and you go down 1 and left 9 from 0, 0. Now, to be perpendicular to that, we know lines that are perpendicular to each other, they end up intersecting each other so that they're 90-degree angles. And so to be perpendicular to this line, we know it looks something like this. And it only makes sense then that if the first line went up 1 and over 9, our line that's perpendicular to it is going to have to go up 9 and left 1. And down 9 and right 1. Forming the 90-degree angle. And so now we say that the slope of the line perpendicular to it, our rise was 9, our run was -1, and so that's a -9 over 1. We say that 1/9 and -9 over 1 are reciprocals of each other. Not only are they reciprocals of each other, they are said to be negative reciprocals of each other. Opposite reciprocal. You can see definitely why one of them is a positive slope and one of them is a negative slope, and now you can see why they are reciprocals. So that leads us to the definition. Two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. So if you have a line whose slope is 3, the line perpendicular to that is going to have to be the negative reciprocal, -1/3. If you have a line whose slope is 4/5, the negative reciprocal of that is -5 over 4. If you have a line whose slope is -8, the negative reciprocal of that is 1/8. Practice 1 is for you to try. I encourage you to press pause on your video and tell me what the slope of a line perpendicular to the line whose slope is these 3 different numbers. And come back when you're ready to see the answer. All right, now that you've had a chance to work this out, the slope of a line perpendicular to the line whose slope is -4, that's a -4 over 1. So the line that would be who have a slope perpendicular to this would be 1/4, negative reciprocal. -2/3, the negative reciprocal of that is 3/2. And 1/7, the negative reciprocal of that is -7. So now, to determine whether two lines are perpendicular, we look at their slopes and we ask ourselves, are they negative reciprocals of each other? In letter A, the first line is or has a slope of 2. And the second line has a slope of -1/2. 2, -1/2, those are definitely negative reciprocals of each other. So we have two lines that are perpendicular this time. B, I can't tell if those are reciprocal by looking at this. I need to have both of these written in y = mx plus b form. So my first equation, 5x plus 2y = 8, I want to get rid of the 5x there, so I subtract it. And that leaves me with 2y = -5x plus 8. Now we divide both sides by 2 to solve for y, and we get -5 halves x plus 4. This line has a slope of -5 over 2. My second equation is 2x minus 5y = 10. We subtract 2x from both sides and get -5y = -2x plus 10. Dividing both sides by -5, I get y equals -2 over -5, which is 2/5, and minus 2. First line has a slope of -5/2. Second line has a slope of 2/5, positive. Two-fifths and -5/2 are definitely negative reciprocals of each other. So we have another pair of perpendicular lines. All right, now when you look at this set of equations again in letter B, you kind of see something here. The 5 matches the 5 on the y. The 5 on the x matches the 5 on the y. The 2 matches the 2 on the x there, 2 on y, 2 on x. And then the sign change there, that's indicative of negative reciprocals. When you can swap your variables and one has a negative, it all works out to be negative reciprocals in the end. So just something to look out for. Or you're always welcome to write them in slope-intercept form. This concludes the video for section 3.6, Parallel and Perpendicular Lines. Objective 3, determine whether two lines are perpendicular.